Hello, my name is Evan, and I'm a second year student studying applied cybersecurity and computer forensics at the University of South Wales in Newport. I have been asked to prepare a short video explaining the TCP/IP and OSI networking models. Today, I'll be focusing more specifically on the encapsulation and de-encapsulation process. However, before we begin with that, I would first like to briefly outline the OSI and TCP/IP and network models. First, I would like to discuss the origin of networks as we know them today. The first network was developed by the US Department of Defense in 1969 and was named ARPANET. After this development, other companies began their own development of such networks, namely IBM. However, the problem here is that all of these solutions were proprietary, meaning that two IBM computers could interact with one another. However, an IBM computer and a computer of another make could not. Due to this, they began the process of developing a universal standard that would allow computers and systems of all makes to interact and share data and information with one another. The chief among these was the OSI and TCP/IP networking models. OSI was first developed in the mid-1980s and looked to be the model that would be adopted in full. In the early years of networking, OSI was the primarily used model. However, in the early 1990s, the TCP/IP model ended up becoming the primary model used. This was for various reasons, however, chief among them were that it was cheap and agile. However, there are those who believe it is less comprehensive. Despite this, the OSI model is still often referred to and has an impact on networking to this day. Here you can see a table outlining the OSI and TCP/IP models. For the sake of reference, the OSI model stands for Open System Interconnect, whereas the TCP/IP model stands for Transmission Control Protocol and Internet Protocol Model. As you can see, the TCP/IP model contains 4 layers, whereas the OSI model contains 7 layers. Despite this, both models operate and fulfill the same functions. One way of thinking of it is that the TCP/IP model is a more practical model used to determine how specific computers should connect to the internet and how data is transmitted between them, whereas the OSI model is a more logical and conceptual model that defines network communications. As you can see, the two models contain many of the same layers, the OSI model containing more. It is worth noting that though TCP/IP is most often used and deployed, the Layer 4 application layer is still often referred to as Layer 7 in reference to the OSI model. This is why it is important to have an understanding of both models, as both are used and are often referenced in conjunction with one another. Here you can see the various protocols, devices, and protocol data units used by each layer. Although I won't be going into detail on such things in this video, it is still important to have an understanding for when we do begin exploring the encapsulation and de-encapsulation process. Moving on now to the primary event of this video, so to speak, we'll be taking a look at a simulated network scenario and taking a look at how the various pieces of data and information travel along the network and what goes on at each layer. As you can see here, I have prepared a small sample network just for the purposes of this video. As you can see, we have 2 devices on this home network, a switch, a router, another switch, and then the web page. There's also a DNS server here for purposes of resolving the host name for the web server. However, for the purpose of this video, we will not be looking into that. It is also worth noting that I have filtered the traffic in the simulation view here for HTTP and HTTPS only. This is primarily for brevity's sake, to ensure the video is conducted in a timely manner, and also to ensure things don't get too overly complicated. With all that having been said, let's open up Jane's PC and her web browser and type in https://usw.ac.uk and then click search. Now we can begin looking to see how the data travels. So as you can see here, we have the data being prepared by Jane's PC. And you can see in the simulation panel, we actually have two bits of data. One of these is the actual data itself being sent, whereas the other is the preparation of the data being sent. So if we open up this piece of data here and take a look, here we can see we are on layer 7. And what is happening here is that the application layer is sending the HTTP request to the HTTP server. As we move down to layer 4, we can see that the TCP protocol is being used. Though it is outside the scope of this video, it is worth noting that when dealing with layer 4, the two protocols you will most often see is TCP and UDP. Put simply, the difference is that TCP is more reliable as it ensures that a message has been received, and there are mechanisms in place to check that, and if the message has not been received, to send it again. Whereas the UDP protocol is considered faster, however it is less reliable as it does not have such mechanisms in place. So as you can see here, the TCP protocol is being sent from the source port of 1035 from Jane's PC to port 443 on the USW server here. As you may know, port 443 is the HTTPS port, so that is where our request is being sent. At this stage, the data is referred to as a segment, and a layer 4 header has been added onto the data. As we continue on to layer 3, we can see at this point a layer 3 header has been added to the data, and this is referred to as a packet. And at layer 3, you can see we have the source IP address being that of Jane's PC, and the destination IP address being that of the USW web server. If we continue on once more, you can see we have the layer 2. At layer 2, a layer 2 header and layer 2 trailer has been added to the data, and this is referred to as a frame. As you can see here, the source MAC address is that of Jane's PC, whereas the destination MAC address is not that of the server, but instead is that of our router. And then at layer 1, we can see the port through which the physical port through which the state is being sent in the binary bits, and in this case it is through the fast Ethernet 0 port. Okay, we can now move on to the next stage in the movement of the data. You can see the data has now been sent to the switch. A switch is a layer 2 device, which means it can only see layer 2 and layer 1. So here, the switch has received the frame and looks at the data provided to it. It sees, okay, the source MAC address is that of the PC, and our destination MAC address now is for the router, and we're going to send this data forward through the fast Ethernet 0/2 port. So basically what the layer 2 is saying, it's telling the router where the data has come from and where it is being sent to. Okay, we can now move on to the next stage. If we watch, it has now been sent to the router being a layer 3 device. You can see layer 3, 2, and 1. So it looks, the router, at this stage, the router begins the de-encapsulation process. So the router looks at the data that has been sent to it. It checks layer 3 and sees, okay, it has come from the PC on this network, and it has been sent to the server on this network. You can see now it now changes layer 3, because it can see, okay, to begin with, when I received this data from the switch, the source address was Jane's PC and the destination address was myself. But now moving forward, I need to change that. So the source address, the source MAC address has been changed to that of the router, and the destination MAC address has been changed now to the web server. So it then encapsulates this data and sends it on to the switch. Okay, so the switch once more looks at layer 2 and layer 1. The switch looks at this MAC address table and sees it has come from the router, and resolves to see that the destination is that of the web server. It knows its course and therefore is able to send its data, the request, forward. So finally, the data arrives to the web server. The web server now can see all 7 layers, and it's able to see, okay, this is meant for me. So it begins the process of basically encapsulating once more. So it packages up the data that has been requested by the PC. You can see here in layer 4, the source port is now 443, and it's been sent to port 1035 on Jane's PC. The source IP address is now that of the web server, and the destination IP address is now that of the PC. And as you can see, likewise, the Ethernet source is that of the web server, and the destination is that of the router. So it now begins this process once more in reverse. The web server sending that data over to the switch, which in turn sends it to the router, which then sends it to the switch once more, and finally the data is received by the PC, and we can see now that the web page has been accessed, and Jane is able to view its contents. Thank you very much for watching. I hope you learned some of this video, and I hope you continue on this journey of education.